Okay, now we're going to talk about how to multiply functions. Here we have an f function, x squared plus 3x plus 2, and we have a g function, 2x squared minus 2. Now here's what gives us our instruction. It says find f times g of x. Notice it's a closed-in circle, not an open circle that would imply composing the functions. We're just going to multiply them together. Now we have 3 terms in one, 2 terms in the other. In this kind of situation, I really like to use a box because it helps us keep track of all of our terms. And so across the top, we're going to put the x squared plus 3x plus 2. And down the side, we're going to put our 2x squared minus 2. Now, if you've never used a box for multiplying or factoring before, it goes kind of like this. Everywhere the column meets the row, you're going to enter the product, just like you would in a multiplication chart. So the first cell gets filled in by 2x squared multiplied times x squared. So 2 times 1 is 2. X squared times x squared is x to the 4th. We move to the next cell. We have 2 times 3, which is 6. X squared times x is x cubed. Our exponent rules tell us that when the base is the same, we can add the exponents. 2 plus 1 is 3. And in the last cell, we have 2 times 2, which is 4, x squared. So we're through with the top row. Now we have x squared minus a negative 2. It's just negative 2x squared. A negative times a positive gives us a negative 6x. And a negative times a positive gives us a minus 4 for the constant. Now all we need to do is check to see if any of our terms with variables have exponents that match, so we can combine all of our like terms. And I see an x squared here and an x squared here. So that'll be the only combining we need to do as we bring our final answer out of our box. So our final answer is 2x to the 4th plus 6x cubed. For the x squared, we have 4 minus 2, which is 2x squared. We have a minus 6x minus 4. Now we have multiplied the two equations together, combined like terms, and so here would be our f times g of x. Multiplying functions.